Welcome to this course on machine learning using Python programming. In the previous lecture, we have seen R square metric that is used for evaluating different regression models. And in today's lecture, we will see what are the problems in R square, and then we will see another metric, that is adjusted R square. So, we have already seen R square. It is defined as 1 minus SS residual upon SS total, and then we have seen its value may be 0. Then in that case your model is equally good as the average line. If its value is 1, then it is the ideal case. So, it means SS residual is 0, and if R square is less than 0, in that case it is negative and your model is working worse than the average line. So, R square is giving you goodness of the fit of the model, but now we will see what are the problems in R square. So, what happens in case of multiple linear regression? Suppose your model is y is equal to b naught plus b1 x1 plus b2 x2, and if we want to check the impact of new independent variable, suppose we are having now one more feature and we do not know whether that feature is relevant or not. So, in that case we do not know whether we should add a new term b3 into x3 in our model or not. So, what we do as per R square, what we can do, we can train this first model y is equal to b naught plus b1 x1 plus b2 x2, and then we will train this another model y is equal to b naught plus b1 x1 plus b2 x2 plus b3 x3. So, it means we added one more feature here, and then we will calculate R square of this model, R square of this model, and what if this feature is important, in that case R square should increase. So, whatever R square is here, R square of this model should be greater than R square value of this model, and if this feature is irrelevant, in that case R square of this should be less than R square of this model. But what happens if we are adding new features in our data set that are not relevant? Even then R square will not decrease. So, we want that if we are adding some feature and that is not relevant, in that case R square, because R square gives you the goodness of the fit of the model. So, in that case R square should decrease because we added a feature that is not relevant. So, corresponding y prediction will not be good or better than the previous model. So, here what happens, when we are adding any new variable, it will always find, means generally there is always some correlation between y and x3. So, it will find any correlation between y and x3, and because of that it will give you some value for b3, and the value of R square will always increase. So, while x3 is not related, y is not depending on x3, x3 is not relevant, even then your R square value will increase when you will add this term. So, what we do, there is another metric that is proposed, that is adjusted R square. So, what is adjusted R square? Adjusted R square is defined like this: 1 minus R square into n minus 1 upon n minus p minus 1, where n is the number of instances in your data set, R square is the R square metric, and p is the number of regressors or number of independent variables or number of predictors. So, when we will increase number of independent variables, so suppose we do not know whether we should add a new variable or not. So, we will add So, in that case we are increasing value of p. So, what will happen, this denominator will decrease because the denominator is n minus p minus 1. So, this denominator will decrease, and then what will happen, this ratio will increase, n minus 1 divided by n minus p minus 1, this ratio will increase, and since this ratio will increase, so adjusted r square will decrease. So, in that case adjusted r square will decrease. So, what we are doing, if we are adding any new independent variable in our model, our new metric adjusted r square will decrease because we are adding. So, it is showing what is the idea, that if we are having more features, in that case it will reduce, its value will reduce. But if that feature is important, then see what is happening here. In that case, if that feature is important, then r square will definitely increase. Then if r square will increase, in that case 1 minus r square, this will decrease, and when 1 minus r square will decrease, in that case adjusted r square will increase, because this 1 minus r square decreases. So, what happens when we are adding any new variable, if that is not important, in that case our adjusted r square will decrease because we added one more variable, and this will definitely increase, but it will not increase that much because that variable is not important. So, we added this penalty term, and because we have seen r square was always increasing. So, r square was always increasing, but it is it is because of increase in r square, definitely adjusted r square will increase, but since a new variable is added, because of that adjusted r square will decrease. So, if that variable is important, in that case this increase, because of this r square increase, adjusted r square will increase more than the decreased value of because of p. And if that variable is not important, in that case it will not increase that much. This term will be more important, or adjusted r square will decrease because of this term more than increase because of adding a new variable. So, in this way adjusted r square helps us the evaluation of regression models better than r square metric. So, now we have seen number of regression models, and we will now going to start classification techniques. So, I hope you are knowing difference between regression and classification. We have already discussed it in the starting few classes. In case of regression, your variable that you want to predict is numerical variable. In case of classification, your variable that you want to predict means your response variable is labeled variable, or you can say you have classes that you need to predict in case of classification, and in case of regression you will need to predict numerical values. So, the first classification algorithm or machine learning model that we will study is decision tree classification. So, we have already seen decision tree for regression problems, and that time we have discussed that decision tree can be used for regression as well as classification problem. So, when it is used for regression, it is called as a regression tree, and when it is called as when it is used for classification problem, the tree that is learned is called as classification tree. So, the idea is same. When we are using decision tree for classification, we are creating a model, and that model is nothing but a tree, and decision rules are embedded in that tree, and using these decision rules we will predict the class of the given new instance. So, again tree is formed by splitting the data set in different parts. And so let us see in this when we will study now decision tree for classification, we will study decision tree in detail. So decision trees are very popular machine learning algorithms, and these are not new algorithms. These were proposed many years back, and when these recent models like ensemble models were proposed, like random forest, gradient boosting. So these models were proposed. Then the importance of decision tree was researchers, they found decision tree more important. So we will see that there are different variations of decision trees, ID3, CART, assistant, these are different algorithms for decision tree, and we will see how these are different. But the idea behind decision tree is any of these algorithms is same, that we will split the data set in different parts, and then we will try to find out the prediction based on the decision rules that are embedded in the tree. So in decision tree we will have two types of node, decision nodes and leaf nodes. So let us see the working of decision tree. So generally the first step is begin the tree with the root node, and that root node is suppose S. So this root node is corresponding to the whole data set, and then we will find the best attribute in the data set using attribute selection measure. So attribute selection measure is a metric that can be used to find out which particular feature we will use to split the whole data set, and then using that attribute we will split the data set in different subsets, and so in this way the children nodes of that root node will be created, and we will do the same with these children nodes. We will divide, we will split them again, and for splitting we will find attribute selection measure to decide which particular attribute or which particular feature we should use to divide that node, and this we will do until the stopping criteria meets. So at that time we will stop and the model is learned. So suppose this is the data set. So in your data set you are having two classes. So since this is a classification problem, so definitely the response variable will have classes. So let us talk about binary classification. So there are only two classes in the data set. There are few instances for which their response variable value is suppose red class, and for other instances response variable value is green class. So there are two classes. This is binary classification problem, and if we are plotting it in the scatter plot, we are getting this scatter plot. So you see these are the instances that are corresponding to one class, that is green class, and these are the instances that are corresponding to red class. Now as we have already seen how decision tree works in case of regression problem, the idea is same. This data set will be splitted. So suppose first it is splitted here. So now this is one subset, this is another subset of the data set. It is again, this portion is again splitted. So when we split it, so now you can say that in this subset there are only instances that are corresponding to green class. Here we have only instances that are belonging to the red class, but this subset is having mix of instances that are green as well as red. So, we will again split it. So, after splitting again we got a subset that contains only ret class instances, but it contains both instances. So, we will suppose we split it here. In that case, now again two subsets are created. So, and both of these are pure subsets, in the sense this subset is having only green classes, this subset is having those instances that are belonging to the red instances. So, after splitting, you can say that sets that you are getting are pure, in the sense instances in those sets are corresponding to only one class. So, how we can use it for classification purpose? So, suppose after splitting you are getting this and any new instance is coming. So, you will find out whether that new instance is belonging to this subset or this subset, or to which particular subset. So, suppose a new instance belongs to this subset. In that case, we will predict its class as green class. If that new instance belongs to this subset, we will predict its class as a red class. So, in this way decision tree can be used for classification problem also. Now, we will see in detail how this split is done, because we have seen that in case of regression as well as in case of classification, how decision tree works by splitting data set in different subsets. So, let us see that. So, the idea is we are splitting to try to minimize entropy. So, we can say that your splits are optimal, that will maximize number of points in each one of these new leaves. So, in each leaf you are having similar data points. Similar data points means their classes are same, and then you will say that your split is better split. So, so when we say entropy, so definitely entropy means in that leaf we are having only instances corresponding to one class. So, we will see one example. We have seen it here, the split was done. So, the rule that is used for splitting is x2 is less than 60 or x2 is greater than equal to 60. So, now this node is corresponding to this subgroup and this node is corresponding to this subgroup or this subset. So, then again we split it as x1 is less than 50 and x1 is greater than equal to 50. So, here we split it this portion as x1 is less than 50 or greater than equal to 50, and here we will use x1 is less than 70 or greater than equal to 70. So, this here you see when x1 is less than 50, so x1 is less than 50, then all these instances are having class green class, and for this subset all the instances are having red class. So, that information we put here in the leaf node, that these are the this is the subset in which all the instances are of green class. In this subset, so this subset is basically corresponding to this subset. So, in this subset all instances are the red subset. Then using this 70, x1 is less than 70 and greater than equal to 70, what we got? We got this subset and this as a total subset. So, this subset is corresponding to red class and it is mixed So, we will again split it, and after splitting what we will get, x2 is less than 20, then this is the red class. So, x2 is less than 20, this is a red class, and if x2 is greater than or equal to 20, it is green class. Now, this is the decision tree that has been learned from the data set. So, this was the data set and this decision tree is learned, and you can find out these are the rules that are embedded in the tree. So, first rule is x2 is less than 60, then we are going to this subtree. If x2 is greater than or equal to 60, then we should go to this subtree. Then again there is another rule, if x1 is less than 50, then we are going towards this. If x1 is greater than or equal to 50, we are going towards this. So, now suppose any new instance is coming. So, when new instance will come, it means you will get its value of x1 and x2. So, based on when you will get new instance, suppose new instance, suppose 40 and 80. So, let us see what will be the class of this new instance, whether it will be green or red. So, what we will do, this is x1, this is x2. So, first of all we are checking this decision rule. So, if x2 is less than 60, so x2 is 80, it is not less than 60. So, we will go towards this. So, then we will check if x1 is less than 50. So, x1 is 40. So, yes, x1 is less than 50. So, we will go here, and here we are seeing we are getting a leaf node, and leaf node is suggesting that the class of this instance should be green. So, in this way during testing we will classify the new instance. So, during training this decision tree is formed, and during testing when we are getting a new instance, so we can using this decision tree that has been learned earlier, we are finding the class of these new variables, new instances. In the same way, suppose we are getting a new instance that is suppose that is 50 and 30. So, again let us see how during the testing time its class will be predicted. So, 50 and 30 means x1 is 50 and x2 is 30. So, x2 is 30, it is less than 60. So, we will go towards this, and then here x1 is tested. So, x1 is 50, that is less than 70. So, we will go towards this, and this is a leaf node, and it is suggesting that the class of this instance is red class. So, in this way we can we have seen how decision tree can be used for classification case. The problem is we have not seen till now how this split is done, how we are deciding we should split first using x2, why not using x1, how we are deciding we should take this value 60. So, why we are dividing the data set initially as x2 less than 60 and x2 greater than or equal to 60, why not x1 less than 20 and x1 greater than or equal to 20, and then so here we are having only two variables, only two features, only two independent variables, but suppose we are having number of independent variables, large number of independent variables, then how we will find which particular attribute we should choose at a particular step. So, if we are suppose in any data set we are having age, salary and address and marks and number of credits. So, these different features are there. So, which particular feature you will use at a first step to split the data set. So, we will see how we use this, and here what we have assumed that when we are dividing, generally we will see later that decision tree has difficulty to process continuous data. If your features are continuous features, it is more difficult than if your features are categorical features. You see here, if x2 in this case x1 and x2 both are continuous features. So, we are deciding if x2 is less than 60, then this is the first subset and this is the second subset. So, how we will find out this value, whether we should take 60 or 40 or 80 or any other value. But suppose x2 was categorical variable and there are only two values in x2, yes and no. So, it is very easy, we will take, if x2 is no, we will go this side, x2 is yes, we will go this side. Or if there are three values in x2, so if x2 is 1, we will go this side, x2 is 2, we will go this, and x2 is 3, we will go this side. So, it means if your features are categorical features, it is easy to during the split it is easy to form the decision tree, or less work is to be done during the training phase. But if your features are continuous features, then definitely the first task is at each and every step which particular independent variable we should use for the split, as well as we will need to find out what value of that variable we should use for split. For example, at this step we decided, okay, we will use x1 for splitting this subset in 2, as well as we decided by using the value of x1 as 50. We can take value as 70 also. So, we will need to decide which value we should use for splitting that subset at each and every step if your variable is continuous variable. So, this is the difference between continuous variables or categorical variables. So, decision tree will be easy in case of categorical variables, otherwise it will need to do some more work. And we can relate this decision tree as a sum of product. Why as a sum of product? We know sum of product is known as disjunctive normal form. So, sum of product, why we are saying? Because you see here, we can say that now the rule is any instance can be read if x2 is less than 60 and x1 is less than 70, or x2 is less than 60 and x2 is greater than equal to 70 and x2 is less than 20. And then there is another condition. So, we will say or x2 is greater than equal to 60, x1 and x1 is greater than equal to 50. So, there are three conditions, and we are taking all of these three conditions, because any of these three conditions will become true, then the class is red class, and this condition is itself having two conditions that are joined with and. So, x2 is less than 60 and x1 is less than 70, then it is red. So, that is why we can when we will write the rule for predicting classes. So, these rules are corresponding to sum of products or disjunctive normal form. So, in this class we have seen adjusted R square, and then we have started classification machine learning techniques. So, we started from the decision tree, and then we have seen how decision tree can be used for classification problems, and the rules that are learned. These rules are these we can map to the sum of products or disjunctive normal form, and there are few remaining topics in decision tree classification. So, those topics are very important, and these topics are nothing but attribute selection measures that will help us to select attribute or feature or independent variable that will be used for the splitting purpose at that step. So, we will see there are lots of attribute selection measures, and these metrics we will see how these metrics are defined, what are these metrics and how these can be used for splitting the data set. And then we have seen there are different variations of implementations of decision tree, ID3, CART, assistant. So, why these variations are there? Because these algorithms use different attribute selection measures, and in the next class we will see what are these attribute selection measures. So, I am stopping here. Thank you.